We're doing disk and washer method here, both in the same lesson. We're going to start with disk method. Disk meaning it is a solid circle. There's no hole in the middle like what I showed you in that other video. Okay, so we've used integration to evaluate area of regions. We're going to explore integration and volume again. Okay, this is rotating a region about some given straight line. And what we're doing today, it's always going to be rotating about the x or y axis in this lesson. Okay. If a region in a plane is revolved about a line, the resulting solid is a solid of revolution, and the line is called the axis of revolution. Simplest such solid is a right circular cylinder or a disk, which is formed by revolving a rectangle about an axis adjacent to one side of the rectangle. So, for example, consider the region R here, bounded by the x-axis, y-axis, and the line x plus 3y equals 6. Okay, so we're just going to take it at word that that's that line. Now, if you take this region R and you rotate it about the y-axis, so you're taking this triangle and rotating it about the y-axis, realize the solid formed is this cone here, right? Where this right here represents the x-axis, and this right here represents the y-axis. Okay, so this is taking that one place, rotating around, and that forms that cone. Does that make sense how you can see that there? Okay, now to find the volume of the cone, geometry or formula, okay, or just math in general, the formula is 1/3 pi r squared h, or they give us a specific formula, 24 pi. We're not going to be using that formula exactly because we're looking at, okay, if there's just one strip, okay, a strip is sliced through the region, revolved around the y-axis. This is where it's just a basic cylinder, okay? And so when we look at, resolving this one rectangle around, it makes that basic cylinder shape. Let's see, x would represent the coordinate of some point P on the graph and the length of the strip. When the strip is rotated or revolved around the y-axis, it forms a thin disk, dy, so the change in y, okay? That dy or dx is always the height of that disk. So volume, when we do volume of a cylinder is pi r squared h. So thus volume of this disk is pi x, because this is a horizontal cylinder, it's going around the y-axis, so that distance is x. So x squared, and then dy times is the height. Okay, that's kind of the idea of what we're doing. It's just a lot of the issue is going to be finding what is our radius, because it's not, it's not going to just be x or y, it's what is our radius. Okay. So the cone can be created by an infinite number of thin horizontal slices or strips whose sum will create the cone. And that's what you saw. I think the video made a little bit of sense. So you saw what was happening, kind of like with cross sections. The more you put in there, it's going to make that exact volume eventually. Okay? Okay. So let's look at example 1 here, where it asks us to write the volume of the cone as an integral on the interval from 0 to 2, then find the volume of the cone. So, okay, I'm going to give myself a little bit more space to work here. Now, I have to get rid of some of this stuff a little bit. There we go. Okay, so write the volume as a cone as an integral on the interval from 0 to 2. Now, realizing 0 to 2, what are those values? Those are y values, right? That's 0 is right here. 2 is the intersect right there. Okay, and if you go up and look on the triangle above, it shows that, right? Mm-hmm. Now, why are we y values? Because we are rotating about the y-axis. So when we're rotating about the x-axis, we'll work in terms of x. When we're rotating about the y-axis, we'll work in terms of y. Well, keep in mind, this rectangle is perpendicular to the y-axis, right? That's like when cross sections were perpendicular to the y-axis, we worked in y's. If the cross section was perpendicular to the x-axis, we worked in x's. So this one we're going to be working in y's. When we think about this, okay, 0 to 2, the volume, we're going to go through a couple of phases here, is pi. Now, x squared, because that is the distance across here, right? So I'm going to say x squared for the moment, but we're going to switch it out. And then dy, because the height is in terms of y. What is that x? Okay. What we've got to figure out is what is that x? What?
Square root of y.
No. We're not on a parabola. Okay. What do we have for this equation here?
X plus 3y equals.
X plus 3y equals 6 is what we had up above, yes? So
Just a line.
it's a line. We need to know what can we replace with x. So we need to take this equation and solve for, not y, because we're going to be working in terms of y, so we're solving for x. So x is 6 minus 3y, agreed? Okay, and this is because we're starting with probably the opposite of what you prefer. We're rotating about the y-axis, so we're working in y's. So when we go to do this, now you guys realize, first of all, the pi can go out front. Integral to 0 to 2, those are y values. Now instead of x, what is x equivalent to? 6 minus 3y, quantity squared, dy. Okay, and that's how you're going to find the volume. How do we proceed here?
Distribute. Or whatever.
Foil or distribute, however. So if we foil this, first 6 times 6 is 36. Outside, 6 times negative 3y is negative 18y. The insides are also going to be negative 18y, negative 18y, negative 18y, negative 36y. Last, negative 3y times negative 3y
9y squared.
plus 9y squared dy. So pi. I don't want the integral sign here. We're ready to integrate. Integral of 36.
36y.
36y. Add 1 to the power, divide by the new power.
2y squared.
Add 1 to the power, divide by the new power.
3y cubed.
Evaluated from source.
This is same old, right?
Yeah.
It doesn't hurt us to do practicing on this. I know sometimes we want to skip it, but keeping the pi, I'm going to put in 2. What is 18 times 4? Oh,
Is this
Stuff.
the calculator?
I don't know. It's easy enough to do without a calculator.
It's much easier to do.
That's all going to be 0, isn't it? It didn't say no calculator. It's always a good thing to practice our non-calculator skills, right? And in this one, 72 minus 72 ended up canceling out, didn't it? And so that makes it a nice, the math really wasn't horrible to plug into. Okay. That's kind of your intro. Let's see, can we get down to 2 and get 2 done? Possibly. Because, well, that video helped. I mean, I don't feel like I have to.
This would be a really bad place to stop.
Okay. So specifically, what we just did was the disk method, because we rotated this rectangle around and it made a solid disk. Okay? You're not even supposed to know about the washer method yet, but solid disk, no holes in the middle. So that's what we're talking about here with the disk method. Okay? When finding volumes, it's important to focus on what happens to each individual slice or disk as it's rotated around a line instead of thinking about the total volume. A thin slice or strip can be horizontal or vertical. We just looked at the horizontal. We had to work in terms of y. This one, the volume of a disk sliced vertically, okay, it's still, they're using pi r squared w. R is the radius, w is the width. Well, area of the disk. The pi, the radius squared, which is going to be, depending on the problem, and then the width, which is your dx or dy. So, horizontal axis of revolution. This is one, so aka rotating around the x-axis, right? And when you're rotating around the x-axis or any horizontal axis, you're going to be working in terms of x. Thus, you'll notice this one is from a to b of rx squared dx, so that's the radius squared. Vertical axis of revolution, that's what we just did on the previous page. That's going to be solved in terms of y then. So notice it's pi integral from c to d, r of y squared dy. So it's just a matter of which type are we rotating around, what are we working in. Okay? Now, let's look at this one, see how much of this one we can do. Set up and evaluate the integral that gives the volume of the solid by revolving the region about the x-axis. So one thing I like to do, I'm going to pick different colors here, but rotating about the x-axis. You will often see me put like a little rotating symbol. That's kind of my visual reminder. It's a typical calc thing. So we're rotating about the x-axis. What's this graph look like?
Line. Downwards looking line.
Okay, y equals negative x plus 1, so it has a y-intercept of 1, and it's going down 1 over 1. So it's going to intersect the x-axis at 1 also, yes? So intersects the x-axis at 1, 0. Intersects, whoops, the y-axis at 0, 1 if you want to, or just the ones. And obviously we know the origin here is 0, 0. Now, we're taking this region right here that is basically under the curve. And we're going to rotate this triangular shape about the x-axis. Okay, so if you think about it, it's going to be one of those cone shapes, right? Because we're rotating that about. When we talk about disk versus washer, is this going to have a hole in the middle?
No.
No. So just for reference sake, you're always going to want to pause and identify, is this going to be solid or is there going to be a hole in the middle? I need to think washer. This is going to be solid. Let's see, the equation we were given is y equals negative x plus 1. If we're rotating about the x-axis, what variable are we going to work in terms of?
X.
We're going to work in terms of x. So I know they talked about it being r. I don't know if I really, want to talk about being r, but when we talk about volume, it was pi r squared and height, right? Well, we're going to be having, whoops, pi is pi, right? When we talk about r, and I didn't draw in my rectangle. Okay, we're rotating about the x-axis, so that means my rectangle, there's my rectangle, yes? It's rotating about the x-axis. This rectangle has a height of y, if you will. So it's the idea, since we're going to, the y, but what is y going to actually be equal to?
Negative x.
we know y is negative x plus 1, yes? So it's going to be negative x plus 1 quantity squared, because we're going to be working in terms of x. I forgot to fill in my height. What's the width of this little rectangle going to be? The width of that rectangle is going to be dx, and that is just the width there. Okay? So that's all going to be dx there. And dx should match, what are we working in? We're working in terms of x. This is what you're integrating, folks. The only thing we haven't talked about is what bounds to put on there.
0 to 1.
Which 0 to 1?
0 to 1.
Left and right.
X axis.
This 0 and this 1. Yes? Now, I know, stupid question, but it matters, right? Because it's not always going to be the same number. So, volume is the integral from 0 to 1 of pi times negative x plus 1 quantity squared dx. The pi I can move out front. You can integrate as is, but traditionally we tend to do better if we boil it out.
X squared minus 2x plus 1.
I'm with Doug. Are you guys with Doug?
Sure.
You just believing it?
It'll take me some time, but sure.
I trust you.
Okay. And we're ready to integrate. Oh!
1/3 x cubed minus x squared plus x.
Evaluating from 0 to 1.
5.
Doug says you get an answer of pi over 3. My answer key agrees. So, well, let's see. It would be 1/3 minus 1 plus 1, and then it'd be the zeros. So, yeah, it works out pretty nicely. Pi times 1/3, which is indeed pi over 3. Okay, tomorrow we'll practice some more disc on the next page, and then we'll also talk about washer. Hopefully you have a little bit of an idea of what you're doing.
A
Okay?
little bit better than what we had last week.
Yeah.
Okay.
Better than what I got before.